Why do we need the information of time and space to make the right decisions? It is difficult to clearly state what time is, but it is passing by even at this very moment. Today, most of the people can tell time by looking at clocks. However, primitive people felt the flow of time through the position of the sun, the shape of the moon, the birth and death of living organisms. For them, time was not an artificial creation, but a kind of life experience that came naturally in their lives. For this reason, time meant various things to them. The primitive people observed the sun and moon and used it as a standard in making a calendar to distinguish month, date, and time. The calendar is a method of measuring the flow of time from the periodic and regular phenomena that appears in the movement of celestial bodies. In order to divide time and attribute order to dates, units of time need to be decided first. Here, the units of time are defined based on the periodic motion of celestial bodies. Some representative examples of the periodic phenomena of celestial bodies include the change of day and night, the change of seasons, and the change of the moon's phases. The sun, earth, and moon, with a close relationship with the human lives, are rotating and revolving as they push and pull on each other. Ancient astronomers who carefully observed this planetary motion defined the length of a day, month, and year based on the regular and repeating motions found in the sun, the earth, and the moon. Since day, month, and year had cycles independent from one another, they put much effort into combining them together. This effort culminated with the development of an almanac. The calendar we use today was first invented in 1582. Because Roman Catholic Pope Gregory XIII promulgated this calendar, it was named the Gregorian Calendar after his name. The solar calendar, which was created based on the movement of the sun, originates from the Egyptian calendar, which developed into the ancient Roman calendar, Julian calendar, and the Gregorian calendar. Commonly known as Caesar, Gaius Julius Caesar showed much interest in the calendar. The Roman calendar used at that time was very inaccurate. Caesar went on an expedition to Egypt and discovered the simple calendar system used there. He eventually created his own calendar, which is the Julian calendar. Most influential Romans made and utilized the calendar as a display of their status. Caesar was one of such people. He named the 7th month of the year, which was his birth month, Julius. This is the origin of the month of July in English today. The Julian calendar was widely used within the Roman Empire and spread all over Europe. At the end of the 16th century, this was replaced by the Gregorian calendar. The word calendar originates from the Latin word calendarium, which refers to a ledger. This is because debtors had to pay interest on the first day of every month in ancient Rome. Priests, who performed religious ceremonies, observed the new moon and announced the beginning of the month by playing the pipe. The first day of every month at this time was called calend. For the Romans, there were no street lights, so there was nothing better than the new moon to light up the streets at night. For this reason, it is assumed that the beginning of the month was as an important time that marked the starting point that brought people hope and relief. Calendars differ depending on the celestial cycle that was used as its basis. If the movement of the sun in the sky, this is called the solar calendar. The lunar calendar is based on the syzygy, the state in which the sun, earth, and moon line up, forming either a new moon or a full moon. The lunisolar calendar takes into account both the movement of the moon and sun. Looking back at human history, civilizations with the most accurate calendar system could operate a sophisticated political system. The Aztec Empire, often known as the Empire of Gods, created a highly developed calendar. Today, many people know what the solar and lunar calendars are. The Aztecs used the solar calendar with a 365-day cycle and the cultic calendar with a 260-day cycle. The commoners used the solar calendar, which consisted of 18 months, each of which was made up of 20 days. The cultic calendar, made up of a combination of numbers from 1 to 13 and 20 names, was used by priests or for religious ceremonies. Every 52 years, the two calendars ended at the same time, marking the start of a new period. The Aztecs celebrated the arrival of a new era with a new fire ceremony. This helps us imagine what time had meant for the Aztecs. In particular, the discovery of the sunstone later on allows us to figure out precisely what the exact concept of time they meant for them. The Aztecs tried to understand the flow of time and change of history through the creation and destruction of the sun. Civilizations require a calendar by necessity to establish a unified political system where its members feel a strong sense of belonging. The calendar allows people to predict natural phenomena in their lives and members of society to share time to achieve common goals. In this respect, a precise calendar played an important function and role in achieving civilizational goals. As mentioned earlier, the Aztecs, who had built a great empire, had an extremely sophisticated calendar. The two calendar systems adopted by the Aztecs were similar to the solar and lunar calendars used today. Actually, the Aztecs did not invent these two calendar systems. Rather, these calendars were inherited from various civilizations in and around the regions where the Aztec Empire formed and were almost identical to the Mayan calendar. Just like the Aztecs, the Mayans also used two different calendars. Mayans called their calendar with a 365-day cycle Tzolk'in and the one with a 260-day cycle Hab, which was based on. In describing the Mayan calendar, an American astronomer and anthropologist Anthony Aveni said that the 260-day cycle of Hab originates from the syzygy of the Venus, the length of human gestation, or units related to agriculture. He further stated that the 20-day units that appear in the Mayan or Aztec calendar comes from calculations using the human body, the number that can be counted using fingers and toes. The Sanskrit word ksana means a moment. This word is also often used in Buddhism to refer to a very short moment of a thought flashing through a mind. A record says that it takes about 64 ksana for a man cut a string while two other men are pulling each end of the string. In today's concept of time, 1 ksana would be about 1/75th of a second. On the other hand, there is a word kalpa which refers to a very long time that is hard to even imagine. Once in 1,000 years, a Taoist fairy comes down to earth and grazes a massive rock the size of a house with her dress and returns to the heavens. 1 kalpa refers to the length of time it takes for the rock to become the size of a grain of sand through this process. The time that people value the most is now, what we call the present. However, for people, the present is nothing more than a concept of time. There would have been no such concept prior to the beginning of the universe. A sudden and massive explosion occurred when everything was at a standstill and created the universe. Time created at this moment. That is, time came into being the moment space was created. We may say that the concept of time has meaning when it exists with the concept of space. For example, saying, "There is a constellation," upon looking at the night sky is quite different from saying, "The constellation is in that location, so the sun will rise soon." When we come across space and time simultaneously, we can always get useful information. This is why we have to study this topic of mathematics. Knowledge gained separately from either just time or space is incomplete. We may set the present as a point where time and space meets and then look back in the past. By doing this, we may learn what happened between a moment in the past and the present, what stories of the life and death existed, and what traces they left behind through a journey through time and space that remain open to each other. That way, we would be able to predict what time and space would look like as we encounter them in the days to come. The purpose of studying mathematics is to make a prediction program. In order to raise our dimension, we need to be capable of accurately drawing out the concepts of time and space. Can time align events happening in space? About 15 billion years ago, an object of incredibly high temperature and density exploded. After the explosion, space expanded at an extremely high speed for about 10 to 35 seconds. With the expansion of space, the temperature and density decreased and new materials were created. As a result of the creation of countless galaxies and stars, the universe where the humans live made its first appearance. This was the Big Bang that created the space and time of the universe. Scientists today have confirmed that the universe continues its expansion. However, time is invisible because it does not have a specific shape. Time does not also have sound or smell. What we know for sure is that time continues to flow even at this moment. The universe we know today was created by the massive explosion known as Big Bang. The Big Bang theory is a widely accepted theory that explains the universe. According to this theory, in the initial state of the universe, every substance and energy was condensed at a single point, which expanded with a sudden explosion. Observations have found that this massive explosion took place around 13.8 years ago. Put simply, the theory says that everything was condensed into one point which was extremely hot. As the universe suddenly expanded, its temperature became lower. In this process, matters we know of such as protons, neutrons, and electrons were created. The materials converged due to gravity to become stars and became the universe as we know it today. The Big Bang theory is actually based on the general theory of relativity developed by Albert Einstein, a brilliant physicist. According to his equations, the universe becomes gradually smaller and eventually converged to one point as we move back into the past. The universe began with the Big Bang, and the time that has passed since the event is the age of the universe. In 1929, an American astronomer, Edwin Hubble, discovered Hubble's law, which became the observational evidence of the Big Bang theory, which states that the universe is expanding. Today, we can know the time by looking at clocks, but a very long time ago, people could only guess the time from nature. This was possible because although time itself is invisible, it reveals itself in space. For example, the ancient Egyptians thought a day begins with the sunrise. In contrast, the Israelis considered the sunset to be the beginning of a day. For primitive people, the most important unit of time was the day. They endlessly repeated lives of constantly moving from one place to another to forage for food during the day and sleeping at wherever they were at night. For the primitive people, the day that began with sunrise and ended with the sunset was an extremely important unit of time. Kings were called pharaohs in ancient Egypt. The ancient Egyptians regarded the pharaohs as the son of the sun god and worshipped them as a deity. Agriculture was of utmost importance to them, and the people regarded the sun, given its close relationship with farming, as the highest god of all. The pharaohs were living gods, ruling the nation with the absolute power as a political and religious leader. They also mobilized countless farmers and slaves to build massive pyramids. About 80 pyramids symbolizing the mighty power of the pharaohs have been discovered so far. Among them, the pyramid of the pharaoh Khufu is the largest. Its height is 146 meters and the length of each side at its base is 230 meters. This pyramid was constructed with as many as 2.3 million stones with an average weight of 2.5 tons. Within this product of much labor is the mummified body of the pharaoh. The ancient Egyptians thought their soul would be still alive even after death, and by leaving their bodies behind when they enter their afterlife, it would be possible to come back to life. The Egyptians applied substances to the pharaoh's body and wrapped it with bandages so that it would not rot, creating mummies. They built sphinxes to protect the pyramids from demons. The word pharaoh was derived from paro, which originally means great house. However, the meaning of paro changed over time to refer to a ruler. Then, under Akhenaten IV of the 18th dynasty of Egypt ruled, Pharaoh became the word that was used to refer to a king. The word Pharaoh continued to be used throughout ancient Greece and Rome, and changed it to Pharaoh, the word we know today. To the ancient Egyptians, the Pharaoh was a descendant of the gods that ruled the earth from the heavens. The sun god, Ra, chose the pharaoh and granted him the same status as the gods to protect Egypt, the most valuable treasure in the world. A pharaoh was both a ruler and a religious leader. The senior administrative officials helped the pharaoh maintain harmony and justice in the universe. The pharaoh's religious duty consisted of building temples. Because the Egyptians believed the gods needed a place to stay on earth to exert their influence, the pharaoh had to worship the gods and conduct ceremonies by continuously building temples. Therefore, the temples did not just play a religious role but also served as an economic institution that produced, managed, and distributed national wealth. To the ancient Egyptians, the death of the pharaoh meant the fall of the sun. It was a major event that disrupted the harmony of the universe. During the funeral, The people desperately waited for an heir to end the chaos. As their only hope lied in avoiding anarchy, the son or heir of the pharaoh was enthroned as quickly as possible. Regardless of the era, solving economic problems related to food has been a basic and important duty for rulers. Because of the importance of agriculture, the sun was the object of worship, leading to the emergence of the sun god in pharaohs. As people gradually started to settle down and cultivate crops and raise livestock, there was a need for a unit longer than a day. People started to observe aspects of time embodied in nature and discovered that the moon returned to the same shape once a month. They also realized that seasonal changes repeat their cycle every year. The most important thing in agricultural processes was knowing the change in seasons ahead of time. Then, why do seasons change? The seasons of the year refers to the change of climate that happens in a yearly cycle. Seasons change due to the Earth's orbit around the Sun while tilted toward it. Seasons vary from place to place. We may tell seasons apart by the location of the Sun in the celestial sphere. When the Sun is between the spring equinox and solstice, we call it spring. When it is between the solstice and autumn equinox, we call this summer. Autumn when the Sun is between the autumn equinox and winter solstice, and winter when it is between the winter solstice and the spring equinox the next year. However, because the Sun does not move at a constant pace across the celestial sphere, the lengths of the 4 seasons are not equal. Seasons that were determined by the location of the Sun did not appear on the same day every year, so Asians used the lunar calendar. The solar term, which plays a major role in the lunar calendar, refers to the 24 seasons created by dividing a year into 24 parts. When the Sun is at the vernal equinox, this is the Chunfan. When the Sun moves 15 degrees from the vernal equinox, it is the Qingming. When it moves another 15 degrees, it is called the Guoyu in the lunar calendar. As such, the first day for each 24 solar terms was given a name. The seasons that nature gives us changes constantly, making it hard to identify the moment we move from one season to another as a separate point in time. Seasons are usually distinguished by factors such as temperature, amount of solar radiation, precipitation, wind, atmospheric pressure, and air mass. Because temperature and precipitation best indicates the changes of seasons, they are often used as its indicators. When we distinguish the seasons using these indicators, the beginning and the end and the length of each season may differ depending on the region. In areas that with all 4 seasons, the winters are longer in northern areas, and shorter in southern ones. In contrast, summers are longer in southern regions and spring comes earlier in the south while fall starts earlier in the north. The lengths of spring and fall for the northern and southern regions appear reversed. Using these methods to tell seasons apart, spring and winter are generally longer, while summer and fall are shorter. However, the seasons distinguished by the altitude of the Sun and elements that make up the climate may feel different from the seasons we feel ourselves. We may also distinguish the seasons by natural phenomena we observe, such as animal activities, plant germination, blooming flowers, and falling leaves. This method of telling the seasons apart is phenology. The ecology of animals also changes with the seasons just as plants do. Ecological processes, such as migration, propagation, metamorphosis, and hibernation, are closely related to seasonal changes. Animal phenology is distinguished by classifying the period when a phenomenon first occurs, when it is most active, and when it disappears from sight. Observation of when swallows, a migratory bird, comes and goes is one example of animal phenology. Mosquitoes are another example. The number of mosquitoes is small at the beginning of the summer, which increases greatly after a while. With the arrival of colder winds, they disappear. In this case, we can observe animal phenology by when it first appears, reach its peak, and disappear from sight. Our eyes are not the only means through which we observe. Sound is another object we may observe. When we identify animal phenology, it is extremely important to use sight and hearing. We can distinguish seasons by natural phenomena that we can see, but we may also do so by listening to vibrant or relaxed sounds animals make. Plants change shape and color according to changes in the season. Plant phenology can be distinguished by changes in the plant, as sprouts emerge from seeds, flowers come to bloom, or leaves fall from branches. Knowledge of plant phenology, such as the date of flowering or germination, is very important for farmers. Plants and animals are not the only things that change with the season. Human lifestyle also goes through clear changes according to it. Even within human lives, we may observe human phenology that changes with change of season. Some examples of such changes include clothes, heating, air conditioning, and food. Likewise, human phenology can appear differently depending on the human lifestyle as well as differences in space and time. Today, people regard time as being an independent quantity. However, we can see that people in the past thought of time and space together as one. To them, time meant an alignment of events in space. Without time, events that happen within space would be mixed up, and without space, time could not exist. For most people, time was an absolute concept, and most believed that time and space always flowed at a constant speed. However, Einstein's theory of relativity proved that this was wrong. The following statement would help us elevate our dimension of space and time. What would happen if we were to look at the light while traveling at the speed of light? Because the answer to this question is contradictory to the common notion that the speed of light is constant, it appears confusing. For example, let us say a baseball player throws a ball at 140 kilometers per hour. To a person standing still, the speed of the ball will be 140 kilometers per hour. However, to those traveling in the same direction as the ball at 100 kilometers per hour, the speed of the ball will be 40 kilometers per hour. Then what will be the speed of light to those moving at the speed of light? This was a question that Einstein had since his childhood. Logically speaking, if we were to measure the speed of light while moving at the same speed, it should appear to be not moving. However, according to Einstein, the speed of light is constant at 300,000 kilometers per hour. The speed does not increase or decrease. Regardless of the source of light or motion of the observer, the speed of light is always constant. Motion refers to a lapse of time relative to the position in space. Thus, time and space presume the existence motion. In physics, this time and space are called absolute time and absolute space. This is a generalizable principle that may be applied anywhere in the universe. Time does not speed up or slow down, and space does not contract or expand. However, according to Einstein, time and space are not absolute, they are relative to the observer and the observed subject, and the higher the speed, the more significant this difference becomes. What happens if time and space communicate with each other? Navigation refers to a technology that helps ships and planes arrive safely at a destination on time. Locating the current location and setting the route that will follow are the most important tasks in navigation. We may figure out the location of a ship by observing lighthouses or mountains on land or by taking consecutive measurements of how deep the water is. At the distant sea surrounded by only water, sailors used to calculate the location by measuring the altitude of the stars in the sky. For example, it is very unlikely that Vikings sailed across the Atlantic to Greenland and North America by only following the coastline. They would have set their direction at distant seas by observing the North Star, constellations such as the Big Dipper, and the Sun. With the advent of the 15th century, navigation started to develop through scientific research, leading to many monumental events. Bartholomew Dias discovered the Cape of Good Hope in 1487, and Christopher Columbus discovered the American continent in 1487. At the end of the 15th century, Vasco da Gama pioneered a sea route to India, and Ferdinand Magellan was the first to successfully circumnavigate the world in the early 16th century. Such great voyages were possible because they had the compasses, altimeters, and documents that recorded changes in the position of stars according to dating time. Especially in the 18th century, marine chronometers, which were nautical clocks, were invented, allowing those at sea to accurately calculate the position of stars. Animals such as migratory birds and salmons have unique means to find the direction they wish to travel. However, humans are not born with innate abilities to recognize their locations. People in the past had to observe celestial bodies like the North Star, the Sun, or the Moon and compare it with pre-calculated tables to figure out their position. A drawback of this method is that it does not work in bad weather or during the day. Today we have the global positioning system, which is not affected by time or weather. GPS is a system that uses satellites to tell us the location, speed, and time no matter where we are in the world. GPS calculates the current location by analyzing the radio signals from the 4 satellites orbiting the Earth. The precise distance between the GPS satellite and GPS device can be found by analyzing the time information sent by the GPS satellite radio signal and calculating the distance light travels according to the time difference. Today, GPS is most widely used in automobile navigation systems, allowing us to avoid heavy traffics and go to new places. It is also used in control systems that locate and notify the closest police vehicle near a crime scene. Self-driving cars are future cars that drives itself without human control. Today, the competition to develop self-driving cars is intense all around the world. Until now, the development of automobile technology has been dominated by car manufacturing companies. However, when it comes to self-driving cars, the role of information technology companies has become bigger. Google, an IT company that started out as a search engine, and NVIDIA, a graphics technology company, are notable examples. These companies are developing self-driving cars using high-tech sensors that can detect obstacles in the surroundings and high-performance graphics processing units. These cars obviously also use GPS technology. To catch up with such innovative transformation, traditional car manufacturing companies have begun to replace the engines, which we may call the heart of the car, into batteries and are incorporating mobile devices such as smartphones or smartwatches into the automobiles. The most important technology for self-driving cars is sensor technology. High-performance sensors can measure the distance between objects like humans and detect danger in advance. Every sensor has a different role and has different measurement capacities. For example, laser equipment measures distance by analyzing the laser reflected back from obstacles. It can detect all 360 degrees from the sensor and read new information as many as 1.6 million times per second. The 3D camera, mounted to keep an eye on the front, allows the vehicles to monitor the road conditions in real time. 3D cameras measure distance more accurately by comparing pictures of objects from by 2D cameras. Human eyes use the same principle to recognize distances. As such, the world has entered an era where space and time communicate with each other, and people and machines move as one.